We want to describe the type of translation that would occur to the basic function f of x. We're given f of x plus 4, f of x minus 4, f of the quantity x plus 4, and f of the quantity x minus 4. Looking at these first two examples, notice how we're adding or subtracting 4 from f of x, which would be the function value or the y value. So because we're adding or subtracting a constant to the y value, these two will shift the graph up or down. But notice for these last two examples, we're adding or subtracting 4 from x, which would be along the horizontal axis, and therefore these two will shift the graph left or right. Let's look at an animation to illustrate these translations. Let's start by looking at what happens when we add or subtract a constant from f of x, the function value. Notice as we add a constant, the graph is shifted up. And if we subtract a constant from f of x, we can see the graph is shifted down. So this answers our first two questions. F of x plus 4 will shift f of x up 4 units. And f of x minus 4 will shift f of x down 4 units. Now let's go back to the animation. Now let's add and subtract a constant from the input x. Notice as we subtract a constant from the input x, the graph is actually shifted right, which might be the opposite direction that we would think. But if we pause here for a moment, this should make sense. If we take a look at the red function for a moment, notice that when x is 0, the function value or y value would be 0. But now looking at the blue function, f of the quantity x minus 1, notice how it would take a larger x value, or in this case an x value of positive 1, to get the same function value or the function value of 0. Because we're subtracting 1 from x, it'll take larger values of x to get the same function values, and therefore shifting the graph right. And if we add a constant to x, the graph is actually shifted left. And if we pause here for a moment, notice how it's going to take smaller values of x to get the same inputs as f of x, and therefore resulting in the same outputs. Notice for the red function, f of 0 would be 0, but for the blue function, it would take x equals negative 1 here to get a function value of 0. So if we have f of the quantity x plus a constant, the graph is actually shifted left. Of course, assuming c is positive. So f of the quantity x plus 4 will shift f of x left 4 units, and f of the quantity x minus 4 will shift f of x right 4 units. Now before we go, let's consider the basic function f of x equals x squared as an example. If f of x equals x squared, then f of x plus 4 would be y equals x squared plus 4. F of x minus 4 would be y equals x squared minus 4. And f of the quantity x plus 4, notice how x plus 4 becomes the input into our function. We would have y equals the quantity x plus 4 squared. And then finally, for f of the quantity x minus 4, we would have y equals the quantity x minus 4 squared. I hope you found this helpful. I'll leave you with some notes that will summarize what we just discovered.